Good morning, everyone. I hope everyone's doing good. Let's save that. Let me just share this live stream with everyone. And yeah, we're running it back. Who would have thought we did 9 hours yesterday streaming? We're going to roughly do the same amount again. Doing the same as yesterday. Just share this out. I was a bit late coming back from the gym. That's why we're starting about 10 minutes later than yesterday. So yes, the course of events is still the same as yesterday as well. We're going to do revision for about an hour. Let me just get up my Toggle Track app. As you can see, I'm a little less prepared because I had to rush things around. I'm also going to talk a little quieter because my voice is a little sore from yesterday, and I think that's just because I was yelling, basically. Well, not yelling, trying to be heard. So my goal with that is to basically get closer to the microphone. And we'll see how we go from here, right? Because this is my normal talking volume, so... someone said yesterday that you've got to think about your voice box as a muscle. So, yes, we're going to be a bit quieter, more or less. Sorry about that. There we go. Got it. Just getting up the chat. That's what that was. Let it load. Okay. Yo, Shadow Dev. Thank you for turning up. Hope you're having a great day, dude. Alright, go to live chats. Fantastic. Present. Here we go. Telepathy. Love it. Alright, let's dig into this. Right, so revision. Then study. Then coding. So that's the things we're going to be doing today in that order. Yep. Yeah, I'm not talented enough to not work hard at this, so let's dig into it. So I will read, just for the people who don't know, I will read my notes out loud. So these are my notes. This is an Obsidian application. I'm probably going to go through the things we did yesterday on graphics theory. We're probably going to do a bit of that studying today, maybe something else as well. So yeah, that's pretty much it. Let's start with what we did yesterday, because that's important. Okay. Because we did basically all this yesterday, so we need to drill it again. Just for anyone who how is the node system for Obsidian from Obsidian? It's part of it. So if you actually use it yourself, I just open up. You actually get this kind of button up here, Open Graph View, and then yeah, you can click on stuff. So it's nice to just like randomly select stuff like, oh, I'm going to read about recreating swap chain, and then go back again and then click on something else, like oh, reverse Z, and then click on something else. That's what I've been using it for anyway, as like a nice way to click on things. And obviously the connections mean that this stuff is related. So swap chain color space formats is related to Vulkan and graphics theory, along with the problem with low dynamic range cube maps and high dynamic range. Like all this is kind of connected. That's the idea. The red nodes are the source nodes, which is where everything kind of comes from. So when I do the studying, I type up the red ones and then I split them off into little grey nodes, because I'm never going to read like a massive, like if I look at this one, for example, this one just goes on and on and on and on and on. Like I'm never going to read this, right? No one's ever going to read this. Like it seriously just goes on and on. So the idea is to split it up into little bits, so it's digestible, and each bit then gets connected to another bit, which is kind of useful, which is what this node graph's about. So yeah, speaking of which, nodes can be this small as well. They can be really small. Okay, so what is linear space? Linear space just means that your color space goes from 0 to infinity if it doesn't make sense. That's if it doesn't make that doesn't make it. That doesn't mean that you're in low dynamic range or high dynamic range. So both LDR and HDR can be in linear space. Okay, swap chain format. So yeah, this is the idea. This is the ideal node size. Less than 500 words, but typically you want to fit it on one screen, in my opinion. So it's just something you read and then you move on to something else. Oh, let me randomize the playlist. It's not randomized. Okay, swap chain color space format. It's what we talked about earlier. When you are dealing with high dynamic range / low dynamic range images, when you are dealing with low dynamic range and high dynamic range images, and doing some kind of lighting in the fragment shader, you have to be, there we go. You have to be careful that the swap chain image format isn't already converting your image to linear space. Hey, how's the reading going? Yeah, not bad. Just started. Thank you for joining us, the Loose Goose, and everyone who's churned up. Like I said, I'm not. We're running it back. I didn't make it part 1 yesterday for no reason. We're gonna do another one. So yeah, just correcting some notes, going over what we did yesterday. You have to be careful that the swap chain image format isn't already converting your image to linear space, as you can do this twice by accident, not by accident, making everything look gray. At a very basic level, if you're going to convert the color space yourself, you need to set the swap chain image format to be a unorm version of the color space. Yeah, that's fine. If you're not doing the conversion, you need to set this to sRGB. Very nice. And there we go, for linear nonlinear. This color image format is how the image will be interpreted by the presentation engine. The conversion happens while doing a read/write operation. Cool. Okay, so image-based lighting. What is image-based lighting? Image-based lighting is a collection of techniques that deals with lighting outside of point lights. And ray tracing, it treats the environment like a big light source. You're basically taking a cube map texture, that should be like this, and using each texel as a light emitter, which makes things look brighter and what does it do? And it makes everything look like it belongs to the environment more. Anyway, so image-based lighting is typically more accurate than some global illumination stuff, and especially ambient lighting techniques. So this could be as simple as setting the whole environment just brightness, bringing up the brightness arbitrarily. There is a reason I want to do this. So this is the reason. There is a reason why I'm studying this. So if I turn off all the debug geometry, everything's really dark unless you get close. So it'd be nice to like light up everything slightly orange, even in the dark areas. I hope that we can get some kind of lighting, but we'll see. If not, I'll just have to add it myself, which is completely fine. So this is the motivation behind image-based lighting. So we use the skybox to light things up, because in space there aren't that many lights. It's not like you can get a turn on a lampshade or something. Anyway. Okay, so we did what is... Okay, so I did this twice. Is it the same thing? Okay, so I don't need to have this twice. This is another reason why it's good to go over stuff. Okay, we can start to introduce... We can start to introduce the physically based rendering with image-based lighting if we take the physically based rendering equation. So the goal here is to do the integral over all lighting directions, Wi, over the hemisphere omega, because we need to consider every light direction solving the integral. This is non-trivial. Unlike when you know all the directions of the light, all the light directions incoming in. So what this is talking about is because, for example, in a point light, we already know the directions with the lights coming in based on some dot products that we can do. This means that, but with image-based lighting, we have to sample every single direction over every single pixel, over basically a hemisphere, which is just a sphere cut in half if you think of it like that. So we need to do two tasks to simplify our calculations. For the first task is to grab all the scene's radiance given any direction of Wi. It needs to be fast. Now I feel like I've missed something out here, so yes, I think I've missed this. It should be in... Oh no. I've written more than 4. Okay, simplifying the physically based rendering equation for diffuse image-based lighting. If you've already passed the cube map, this gets easier to work out. We can visualize every texel of a cube map as one single emitting light source based on the physically based rendering equation. We can sample over a cube map and get our scene radiance based from that direction. You want things to be fast, but we have a problem. You'll need I know this is omega, by the way, but because there's 2 omegas, like here and here, I'm just calling this W. You want things to be fast, you have a problem. You need to handle all directions of Wi over the hemisphere omega, which is far too expensive to do for each fragment invocation, which is what I said earlier. You have to do this for every single pixel. Let's bring up my Discord server. Yes, I have both on another monitor. Although my computer is in power saving mode. Okay, there we go. Right. Okay, so to help with speed, you can pre-compute most of the computation. You can also split the diffuse KD and KS in terms of the BRDF. Can be made independent from each other. Okay. If you split the diffuse and specular parts of the integral, you can focus on the diffuse part of the BRDF. If you look at the Lambert term, which is a constant term, the color C and the reflectance of K, D and pi, these are not dependent on the integral variables. Let's do an S. So you can pull them out like this. This is meant. This means that the integral is only dependent on Wi, assuming that P is at the center of the environment map. With this knowledge, we can calculate or pre-compute a new cube map that stores in each sample directional texel with W0, sorry, here. The diffuse integral and the diffuse integrals result that stores each sample direction or texel with Wi in that function. The diffuse integrals result this will get the diffuse integral. Right, okay, let me just do that again. And the result of the diffuse integral will result in convolution. Okay, so, and the result of the convolution in maths means we are taking two functions that produces a third as an integral project of two functions. An integral of product, I meant to say, not project, of two functions f and g if both f and g are functions. That sounds good. Okay. Here what we are doing is considering all data in a solution set, applying some kind of computation to each piece of data in the same set. In our case, the set is the scene's radiance or environment map, meaning that we are considering a single sample from the cube map. We have considered all other samples and gets I'm guessing okay. Sounds good. Right, so I swear I've missed out stuff, so let me click. Thank you. Yes, we missed this. This is not in the thing. And let's try and get the other one. Yeah, we don't have this either. Oh no, we do. Okay, so this is the... Okay, so the problem with low dynamic range cube maps in physically based rendering. So it is important for physically based rendering that you deal in high dynamic range. Let's deal with high dynamic range properly for both colors, for both color lighting versus linear. And your Vulkan swap chain is in the color space format you expect. This is because the PBR, taking in real physical properties, This is because the physically based rendering is taking in real physical properties. Yep. Without working in high dynamic range, you can't work out the relative intensity of something like a small light bulb and the sun, for example. So for image-based lighting, is based. So with image-based lighting, that's based on the environment's indirect light intensity on the color values of the cube map. Full stop. We need some way to store the light's high dynamic range into the cube map. Remember that we take in physical inputs for the physically based rendering. We need them both in high dynamic range to accurately describe the relative intensity of light. If you use a regular map for your cube map, you're only going to have the intensity that goes from 0.0 to 1.0 for physically based rendering. You need the cube map to be in high dynamic range, not low dynamic range. Okay, so linear light for high dynamic range and low dynamic range rendering. If you're using physically based rendering, all the inputs need to be linear. When you are lighting the scene in linear space, yes. This means you need to do gamma correction. This means you need to do gamma correction at is it after or before? I think it's after you've converted light. Actually, I think I already explained this. This means you need to be careful with how you handle gamma correction to get your light correct. Let's say lighting. Okay, so when doing physically based rendering, you want your inputs to be as accurate to the real world as possible, meaning that when you would R colors for diffuse map, meaning that when you would, what am I trying to say here? Meaning that when you calculate the color, the final color for your diffuse material, things can grow rapidly in low dynamic range, which means it can get clamped to 0.0 or 1.1. There are two ways to fix this: taking the high dynamic range and converting it back to low dynamic range. There's actually three. Toe mapping to low dynamic range. Using the Vulkan swap chain to automatically convert your images to LDR. These things need to be done before gamma correction. you can simply apply a Reinhardt operator at the end of your fragment shader to correct the colors in your physically based rendering solution. The Reinhardt operator works way better when you have some ambient lighting in your scene. This also means that you would need. This also means you want to do any tone mapping in high dynamic range, not low dynamic range, otherwise things look grey. If you're done either just converting to low dynamic range from high dynamic range or tone mapping, or both high dynamic, then the gamma correction can be done correctly, meaning that your scene's color output will be correct for high and low light intensities in theory. Yes. Alright, let's go back to that actually. I think that's everything in graphics theory that we did yesterday. That's small notes. How far did I get? Yeah, I didn't get that far, so alright. So that's good what we corrected. I'll leave let's read reverse Z, I guess. What is reverse Z perspective? When you follow tutorials online, you'll find that they do everything in the standard approach, but the problem with the regular depth buffer is that the precision of the floating point value isn't infinite, and we need to decide where the precision is going to be used for our depth buffer. Did you check the physically based rendering in Filament? I think there's a lot of values there. Filament. In Filament, what is did you check Filament? What's Filament? Is that like a physically based renderer solution or something? Physically based rendering. I see. Okay. This is it's the first time I've heard of this actually. So this is some solution. Filament is a real-world physically based rendering engine for Android. Okay. Nice. So did I check that? Yeah, I'll have to skim through this maybe and see how it handles its materials. Right, so it can pretty much do all the standard materials by the looks of things. Very nice. Yeah, I'll maybe come back to that. Yep. The doc's called. Yeah, thanks for sharing that, by the way. We're gonna dig into physically based rendering more today. So, but today we're just doing revision. Sorry, today. For now we're just doing revision, which is fine. So I'm just reading my notes from yesterday, so I don't end up making mistakes. Hello, it's 12 AM here. Just came in to say hi and then go to bed. I see, Mika. Thank you for joining us, and have a good night's sleep. Okay, so when you follow the online tutorials, they do everything in the standard approach, but the problem is that when you do with the regular depth, the source code is bad, but the docs are amazing. Fantastic. I'll have to look at that because that might be useful for parsing through the maths. But the problem with regular with the regular depth buffer is that the precision of the floating point values aren't, I'm going to say aren't, it's easier to read, aren't infinite. And we need to decide where the precision is going to be used in our depth buffer. The precision of the depth is 1 over z, where z is the z of the world's space. This will map to 0 and 1. If you have a far plane and the near plane, n and f, you have this equation for the depth value. D equals this stuff. Since f and n are constants, d is mapped directly with 1/z. Let's map the 32-bit values to a given depth value. You can see for each depth value we lose a ton of precision near the vertical asymptote. I think in horizontal. Vertical. Horizontal asymptote. Asymptotic. Asymptote. E. Oh, I'm sorry. I don't know why YouTube didn't send you a notification. It's YouTube is actually experimenting with not sending out notifications to people for some reason, because they think that you're not going to watch it. So, yeah, it's unfortunately YouTube is doing some weird back-end stuff at the moment. That's what they said in on one of the videos, at least. Oh, hello, and hello, by the way, guys, Omega Killer and Pure Gameplay. It's fantastic to see you guys again. We're running it back with part 2. Hopefully you're here for it, and yes, thank you for turning up. The reason here is that 0 part of the y axis has a lot more values. On the line graph, and as it explodes to infinity. But what if we reverse the y-axis? So instead of 0 up here 1, we have this idea. The depth values increase so we're just doing revision at the moment, so I'm just reading out some of my notes. This is actually really good, by the way. If anyone's actually coding their own game engine, highly recommend doing reverse Z perspective. It's super good for this reason, that your depth precision doesn't go, it doesn't all get stuck at like the near plane. That you actually have some precision at the far plane. This will stop Z fighting, because floating point values only have a certain level of precision. That's what I'm saying here. The depth values increase. The depth values increase A0 to 0 very quickly, but this is where the line is leveling out to a constant. So you can see this explodes off to, it's approaching infinity, gets exponentially worse, but this is leveling out at the same time. So we kind of get a nice increase in precision down here and a decrease in the values that get sampled in the depth, which is what this y-axis is, depth versus z, which is just how far we are in the game, moving forward and backwards. Anyway, the depth, yeah, so to a constant value at the far plane, this massively improves precision within the depth buffer, especially if you're using 32-bit floats instead of 24-byte ints. This is called reverse Z perspective. Hi Matt, thank you for joining us. Yes, the glories of maths. So we've revised all our what do I go over next? Let's look at my Let's look at my thingy. Okay, so we could do a bunch of Vulkan. We did a load of that yesterday. We did synchronization yesterday. Performance, maybe. There isn't much in operating system really. I did threading in the gym. That's a bit of C++. What did I write in assembly? Yeah, let's go over a bit of assembly. So this is assembly based on the 8086 CPU, which was released a long time ago. I can't exactly remember. So this won't be exactly assembly that you're used to. This will be 16-bit assembly. Whereas when you actually code in assembly nowadays, you at least code in 32-bit. Or x86 as it's called. But the same instructions still exist in 16-bit. Just the registers are wider, so they can store more stuff in. Anyway, so I don't think I'll read all this, but let's dive into the move instruction. Instruction decode with MOV. Instruction decode is a piece of work that the CPU has to do to turn an instruction into a mechanical idea that the CPU can operate and do. A mnemonic is a human-readable, friendly way of representing what the CPU can do. So like MOV, for example, is a mnemonic of a copy instruction. Yes, it's not move. That the CPU can do. Move actually means copy, yeah. If we want to copy something from one register to another, you would write it as... So, as you can see, this is 16-bit registers, right? If it was, yeah, x864, you would put an E for extended. But anyway, anyway, so AX and BX. How this works is that the destination is AX and BX is the source. When we are talking about assembly, these are called operands. So instruction operand, instruction operand, comma. Let me read that again. Instruction operand, comma, operand is the order of destination source. This is always the order for Intel assembly. It might be helpful to think about this as AX equals BX. Here we're using the assignment to show that BX is the source. How this will run on the CPU. It runs the code through an assembler that encodes it to binary that the x86 chip instruction decoder understands. The decoder breaks down the binary. The decoder breaks down the binary down to tell the CPU what to do mechanically. Okay. Registers to register move operation. In x86, the move operation is encoded in 2 bytes, 16 bits. The instruction is read in 1 byte, 8 bits at a time from right to left. Sorry to bother you, but I'll be back in some time. I've got to eat my lunch. It's 2 p.m. here. Yeah, no problem. You don't that's not bothering me at all. Yeah, I hopefully enjoy your lunch. Yeah, and thank you for watching. And see you later if you come back. Yeah, no one should feel like they're interrupting me or bothering me when they're commenting. Honestly, you can spam the chat, well, within reason, as long as you're letting other people talk. But yeah, you don't have to be scared when it comes to saying something. Oh, sorry. My bad. Yes, brother. There we go. That's my reading skills not working for my... Alright, see you later, bro. Yeah, I read brother as bother for some reason. Anyway, in the first byte, there is a bit pattern that tells us that it's a move instruction, which is... how should I read this? Is 100... shall I read this as 1010? I don't know. The second byte is... Oh, okay, sorry, I didn't read the following by 2 bits, the W and the D and W flags. That gives us our first byte. Okay. So what I'm... Hopefully this is... Yeah, have a good lunch, dude. So hopefully... So what's ended up happening here? I don't think my notes explain this, like the basics or whatever. What I'm doing here is I'm looking at what the x86 decoder will be looking at. So when you literally type move AX, BX, as we looked at earlier, the assembly will write this out in binary, and the CPU decoder will look at this, for example, and go, oh, this is a move operation, and then it'll look at 2 extra individual bits as the D and W bits. So this will be an 8-bit part. Now how this works in general is, this is true for every single instruction, by the way. The decoder will have to parse individual parts of the bytes to figure out what the next bytes represent. So this is what the D and W are going to do. They're going to tell us, is this a wide operation? So that does this have more, which tells us, is it a 16-bit number? Again, we're working with 16-bit binary here, assembly. And D tells us if the first thing is the destination or the other one's the source. So I'll read all this and I'll kind of explain it a bit more down here, but effectively what we're trying to extract here is information based on the binary that we extract out from the actual instruction. So here we're trying to figure out how the CPU works. Exactly. So what did the register say to the byte? you son of 8 bits. Exactly. So yeah, that's funny, that. So anyway, so let's so again we're going to talk about this in bytes, and obviously we know that 8 bits exist in a byte. So when I talk about bytes, you've got to remember that there's 8 bits to talk about. So the second byte is made up of 3 components of the MOV instruction: the mod field, which is 2 bytes; the reg field, which is 3 bits. I'm saying bytes. The mod field, which is 2 bits, the reg field, which is 3 bits, and the RM field, which is 3 bits. Together, these 2 bytes, tell us what type of move instructions we are going to do. The mod field tells us if the memory operation is a memory operation or a register operation. Okay. Meaning if we are trying to move memory from one register to another, the move memory from... Meaning if we are trying to move memory from one register to another, move memory from... Yeah, okay. Move memory from a register to RAM or RAM to register. This all gets encoded in the mod field. To copy one value to another register, the mod field should be 1-1, as this is 2 bits, right? When the mod field is 1-1, the reg and RM fields, which are 3 bits each, encode the registers. So the reg is the register field, and the RM field has 2 meanings: R, register, and M, meaning memory operation. So this RM changes depending on what the mod field is. So the binary changes what that means. But this is the simplest operation where you're just trying to move memory from one register to another. Since the destination and source need to be in order, we need to know where the registers go, either RM or reg. To work this out, we need to go back to the first byte after the move and encode after the MOV encode, which is this thing, this 1010. After the move encodes, you have the D field, which tells us what the order is. If the D field is 1, the reg is not the destination. And you got to remember that the destination is second, right? If the D bit is 1, then the reg is the destination. The W bit tells us if this is a 16-bit copy or an 8-bit copy. W stands for wide. So here's something cool if you didn't know. In computing, for the longest time, if you open up regedit at least, if I can get this open. This is a regedit. So this is in Windows. I've got to go in admin mode to open it, because I could break the system, but it's kind of cool. So we can see here that we have something like a word. So a word, for some reason, so we have a byte, which we all know is 8 bits, right? What's 16 bits? It's a word, right? What's 32 bits? A double word. So this is a double word. And sometimes if you have a 64-bit thing, that's a quad word, which is like a Q. And if I can find anything here that has, it's probably unlikely. Just off like a random. But yeah, this is if you've ever messed around with regedit before, which is honestly not a fun thing to do. And now you know why we have D word. What does that mean? Because you can create a new, look, there we go, look, a new D word 32-bit, a new quad word, which is 64. So it's like double 16 and 4 times 16. Yeah, so it's kind of cool. It all comes back from like old school assembly, where a byte is called 16 and a byte is 16. Sorry, 16 is a word and a byte is 8. I just thought that was kind of when I figured that out, learned that for the first time, I was like, oh, cool. Anyway, W tells us if the register we are copying is 16 or 8. The registers are either 16 or 8 bits. So this tells us if we are using an 8/16-bit register. So yeah, some registers are 8-bit only, some registers are 16-bit. So they can store different values based in whatever. Finally, the reg/rm are 3 bits, which encode which registers are going to be used. I think we said this earlier, including the W field, I guess. We now know what the register is, what register we are going to move to. Yeah. Hello, Jackie Jen. I hope you're having a great day. Just doing a bit of revision on assembly. Oh, we looked at this. So here we go. This is where it gets a little bit more interesting. Low and high parts of registers. Registers store 2 bytes in them. Now, this is only true for 16 bits. So we're talking about the 8086 processor in this example, because it's the simplest processor for assembly when it comes to what the actual CPU is doing. Okay, so this is only true for the 8086. Just keep this in mind. There is more. You can store more than just 2 bytes in modern processors. If we are encoding registers that take 16 bits, we then copy all the data. Each byte either higher or lower for some registers, or when we are copying bytes, we use either the higher or lower parts of a register. Wait, automatically can write better software. This is the motivation behind this. So I've spent some time learning like how the CPU works, so I can write faster C++ code, because I know what the CPU is doing. Back in the 90s, like this is what programmers all knew. They all knew how to do this. But no, in the 80s they did. But it's somewhere in the 90s, like CPUs got too complicated that people started to never learn this stuff. And because of that, we've lost some ability in general programming when it comes to programmers across all fields and all spectrums, which I include myself in, to write performance code without thinking about it. What I mean by that is if you don't know this, like there is no way of you knowing really if the compiler, once the compiler spits out whatever you've written code-wise, if that's sufficient or not, or have you given the compiler a good guess on what you can do, right? So if you know how the CPU works, you may be like, oh, I'm going to write my C++ or Zig or whatever to give the compiler the best, to give it a great, to give it the best chance to write optimal assembly / binary code, right? I know it doesn't go to assembly, but that's, you're giving it like, you're making it compile to like the best type of assembly, and this is helped if you understand how the CPU works. So this is what this is supposed to be doing. This is why I've learned this. It's not something you should do as a beginner, but it's something I do need to revise. So this is what we're doing. But we will go back to graphics shortly. If we are copying 8 bits, we need to encode either the low or high part of the register. This is done with move AXBX, which is for the entire 16 bits. For the 8-bit parts, which is ALBL, and for the high parts, AHBH. So these are two 16-bit registers on the 8086. The register's base pointer, what is it called? I think it's stack pointer, stack index, and I can't remember. This is where I need to revise it, because I forget stuff like this. Because this is quite important if you ever use to know what these values are. To this day, it's still the same when you have if you have an error on your own Linux and use Stack Analyzer, like these values come up occasionally in your stack trace. If you've got some like memory leak or something. Anyway, the registers, these all don't have low or high parts to them. What ends up being used depends on the W field encoding, which tells us what gets copied. So when we're encoding the W and D bits in a move operation, these are what ends up happening if we have a 1 or a 0 coded in the first part. And this is what registers. It should be G, not D. These are the register tables. So yeah, these are all 8 bits. These are all these 4 are 16. These 8 bits. So yeah, let's keep going. Okay, so we've done low and high parts. Okay, so effective address calculations, which is this is pretty dense. So feel free to ask questions about this. But this is a Intel specialty. So when you're writing Intel assembly, because there's 2 types, this is what they do, which is pretty typical nowadays. I don't think we have the other types of assembly, which is AT&T, I think. To a register, and a store would be moving a register value from some register to RAM, meaning that you are reading. Okay, so meaning you are reading more than 2 bytes in. So yeah, if we're doing if we're moving to RAM, we also need to know where it goes. So there's more instructions part of the move instruction. So the instruction grows in bytes depending on some of the fields. If the mod field, so let me just pull up. I feel like this is like a little hard to explain. So remember that is the move instruction. This is the W, and this is the 2 bits that we talked about. This is the W bits. Now what we're talking about here is the mod field. So we have mod reg, do reg like this, and we have the r/m. So this is how the CPU decodes it. It goes, this is a move operation. What's the destination and source? Is it wide? Now we're on this part, trying to figure out what type of move operation it is. Is it 1-1? Is it, in this case I just said 0-1, or is it 1-0, right? Because that's going to change the next set of bytes and what these mean. Alright, so that's what we're up to. Hopefully that's cleared up a little bit what's going on. We're actually at this point. And so if the mod is 1-0, then we have 1 extra byte. So this tells us that we have another 8 bits to deal with. So 1, 2, 3, 4, 5, 6, 7, 8. If the mod field is 1-0, then we have 2 bytes. So this would be another 1, 2, 3, 4, 5, 6, 7, 8. Depending on if this mod field is that or that. And if it's 1-1, then we don't do either of these 2 extra bits. Extra bytes. This means that the CPU, this means that the instructions are heavily dependent on the previous bytes as we move along the instructions. So this is quite nasty if you think about it, right? This happens all the time on the CPU. It has to like figure out like how many bytes ahead do I need to read to actually complete an instruction. And this is still true to this day. The CPU has to do a lot of work to decode the instructions byte by byte. So it has to go byte by byte, otherwise it will not figure out what the heck the next step is. At the time, this is allowed for instructions to be packed at the cost of complexity in the decode process. So this saved memory, but now we've got extra complexity that we're still dealing with to this day. A load is, this is what a load looks like. So when we take something from RAM and we stick it in a register, remember that the first thing is the destination. So this is the destination, this is the source. So we're taking something at RAM location 75, and we're moving it into AX, right? Warning, this is actually not as easy as it's made out. Move AX and move BX are special cases. So the binary is going to be different for each. So this is just an example. This is not, unfortunately, the decode instruction is harder to parse when you actually look at the binary. The 75 is a pointer to a piece of memory. If we are using a 16-bit register like BX, we automatically read out 75 and 76. So remember that BX is a 16-bit register. Like I said, 75 and 76 need to be read out, right? The store, this is a store since the address lookup comes first. So this is something that we do let's just say I'm writing assembly, right? And I want to do an operation with BX, and I know something in RAM exists at 75. Then, you know, this is how I'd write it, and then I can do something with BX later on. Warning that MOV 75 is another special case which requires more binary to parse. So we actually have more binary to deal with when we do this particular type of instruction. However, this is like what a normal instruction looks like. A typical instruction looks like this, right? We are taking a base pointer, in this case literally base pointer, and doing some addition on it. This is known as an effective address calculation. These are an Intel specialty. Even though they have changed, they are still around now. This is not general. You have to be careful. You can't just have some random operation like this. For example, like there's a very set amount of things you can do with this. You can't just go like a plus b times 2 divided by 7. You can only do a certain amount of operations with this. Anyway, byte encoding for effective address calculations. So this is just referring what we talked about earlier. So this is what the actual binaries represented. When you have to move bytes like this with 1010 DW, W is for wide registers, D is to, and if the D is set to 1, then we are doing a load, because the registers go first. If D is 0, then we are doing a store. So that tells us, depending on the mod field, right? If it's 1 1, then it just changes the register order of what we're doing. But if we're doing a 1 0 or 0 1, so that means we're actually using the RAM on the computer, then this tells us if we're doing a load or store operation. Pretty cool, right? In the second byte, mod reg rm, you need both the mod and rm fields to encode what the memory is. Okay. The rm field actually encodes the type of equation. So this tells us like what we're going to do here. You have to do in addition on what in addition. Oh, sorry. Equation you have to do. So it's an addition. Yes. Okay. I'm just going to just say this. I have to do. Okay. So that's what the RM field does. Okay. So the RM field, the mod field tells us if we've got a displacement. So hang on. I think I deleted too much there. So the RM field, which is this thing, tells us what type of equation we're doing. We have to do. So it is an addition or what that's in, and that addition is in the RM, I think. Anyway, the mod field tells us if we have a displacement. So tells us if we have a displacement. So the 27 in the base pointer. So that's a displacement. So okay, that's good to know. So what does the mod field tell us? So can I just look up the I'm gonna look up the manual just quickly because I'm a bit confused at the moment. For our assembly, so I'm just gonna look up the 8086 manual. If you can bear with me for a minute while I dig that out. I've downloaded it somewhere, but it's easy because I've just got it referenced, and I think I need to be at page 270. So you can see when this was made, right? 1979. 271. So I was definitely not programming, by the way, at that point. Before you ask, do I remember coding this? No. No, what was it? I wrote this down. Oh. Went too far ahead. Okay, so a second 9-hour stream has hit the Escape on YouTube channel. Hell yeah, bro. I didn't make it part 1 for nothing, you know what I'm saying? Also, why are we doing 8086 assembly? It's just some revision. I just need to know how to do this so I can become a better programmer. This is part of being a performance-aware programmer, so you can write performance-aware code. And it's stuff I have to study off stream because I pay for this course that teaches you how to do this. But I am a bit lost on this particular, like, what I need to see is the actual move instruction itself. It's mod reg rm. Did I get that right? Mod reg rm. Okay, so when I say the RM field encodes the type of equation we have to do. So I'm looking at this guy, right? This is the instruction we're decoding. You see the 1001 DW mod reg RM, and disflow and dishire the displacement values. So we can have up to 4 bytes that we have to decode for one move instruction, and more for others. These are just all the moves that you can do with MOV, and they have different decodes. I actually wrote a decoder for all these, so if you give me binary, I can disassemble it into the MOV instructions as part of homework. So yes, but I'm a bit rusty because I haven't done it in a minute. So let me restart the music. Just cut it off. Okay, so the RM field actually encodes the type of equation we have to okay, so okay, I've just got confused. Right, okay. And it has to be addition. The mod field, okay, the mod field tells us if there's a displacement or not. Fantastic. Okay, so this tells us, what is it? Yeah, RM. RM tells us what the equation is. This tells us if there's a displacement. So when it's 1-1, it's a register-to-register move. We don't have to care about it. When it's 0-0, there is no displacement. A caveat. There is a caveat here. When it's 1-0, we have an 8-bit displacement, which means we have to go into this part here. We have disblow to worry about. And when it's 16-bit, we have a dispy displacement. So that means we have 16-bit displacements. The mod field also tells us if the disblow or disply connect to our bytes. Are connected to our bytes. So if we have an 8-bit displacement, we have a disblow. If you have a 16-bit, we have both disblow and dishire. Yeah, so we have both for displacement 2. Okay, so this is the caveat. There is one case where mod 00 does have a displacement. For some, this is really annoying. If the RM field is set to 110, which is, remember, this guy. So when this is 00 and this is 110, you have something called a direct address, and you have a 16-bit displacement that happens when you are looking at a actual address without an equation. This guy. This is the special case. So we have a direct address lookup here, which means we have a 16-bit displacement we have to worry about on top of this. Even though For 0, 0, it tells us we have no displacement, but only when this register is 110. Sorry, the RM field. Very, very, very cool. The value is in the displacement low and displacement high of the instructions. So that's actually where the binary lives. So when we're actually doing a copy from something, that tells us what the value is when we're doing a load or store. Sorry, let me just say that again. This value is in the displacement. Oh, okay, yeah. I think I was right. This still has the same encoding, it just breaks the... Oh, okay, so yeah, I'm sorry, I'm talking about this. This just breaks the displacement rules. The RM field encodes the 8 equations for you to use. We don't need to know the displacement, but what are the register's addresses that are going to be used in the operation. So based on the RM encoding and the mod field, we can work out what displacement values we have, which come from these guys. So this is where these guys, sorry, I got this slightly wrong. The displacement values that we use in these equations, which are these D8 and D16, come from this part of the binary. So this would be a 16-bit displacement, which would be found, this would be base pointer. So if we look at base pointer, it would be here, right? So the mod field would be 1, 1, and we would have a RM field of 1, 1, 0. Right. Nope, we don't want to. Why is that? Oh, whatever. I'll worry about that later. Is there a way to minus a? I didn't mean to do that. Oh well. These are the equations. These are the equations. What? These equations. These equations are allowed to be used in your instruction. Sure. It's important to note that the base pointer and stack pointer, source index and destination index have no 8-bit parts. They are 16 bits or bust. They have no... Are they always disk below or something? Okay, right, fine. So, yeah, we can't do certain instructions. We can do BX SI plus 16, which is a 16-bit, 8-bit register. Okay. If you try to use base pointer with no effective address calculation, the mod field is not 0, 0. The assembly compiles this mod field to 0, 1. For a 0, 0 mod field is reserved for direct access. Oh, okay, so this is telling us that we can't use this. If we do this, for example, which should trigger this particular case, because this should be base pointer. If you look at BP, this should be BP as well. This is invalid because this is reserved for a effective address. What is it called? Not effective address calculation. A direct. Oh, it's right there. A direct address lookup, which is this thing. Anyway, so yeah, that turns into that, for example. Okie dokie. How long have we been going? Right, we got a bit longer to do a bit of assembly. Immediate to register move. Okay, so this is this instruction we're going to be talking about. With a move instruction encoding of 1011 WREG, this is an immediate to register move. This is used when you have a value that isn't directly encoded into a register. So, oh, sorry, that is that. Okay, so yeah, obviously it's just like put the value in the assembly. put 12 in BX. This is much more effective than encoding a pointer or doing something in memory, since we don't have to do a lookup. It's called an immediate because the values are fetched as part of the instruction. If W is set to 0, we only have a disp low to work with. If the W is set to 1, then we have a disp high 2. Even if the immediate move can be encoded as 8 bits, say the number 12, if the register is 16 bits, it will use both disp low and both low and high, making disp low and disp high making disp high all zeros. So if we have BX, which is a 16-bit register, and we do immediate move with a value that's 8 bits only, this will use all this, but this will all be zeros, because 12 will fit in 8 bits, but this will be all zeros. What about signed displacement moves? I think. Do I even have this? Okay, so we can. Yeah, we haven't dealt with signed values yet, but I don't think we finished. Immediate. Okay, so immediate to register move with an effective address calculation. Okay, this is probably the most complicated move instruction. The encoding here is 11000011. This fella. Wait, there are separate 8-bit registers, or does it mean that there are separate 8-bit registers? Or does it mean that the lower 8 bits? Yeah, so I think I don't know if you were here earlier, TT. But if we look at low and high parts of registers, yeah, we have 16-bit registers, and we have for the 8086, and we have 8-bit registers. And depending on what register it is, it's quite straightforward actually. We have A, B, C, and D are registers, and depending on what the value afterwards is, tells us if it's a 16-bit register. So AX means a 16-bit, CX is 16, DX. All these X's mean it's a 16-bit register, 16 part of the register. We're using the whole entire 16-bit of the register, right? We're using every part of it. That's important, I should say, that when we have AX, we're using the whole of AX. When we have AL, CL, DL, BL, we're using half the register, but we're using the low part. When we have AH, CH, DH, and BH, we're using the upper half of the register. So it's just the same register, I think. I could be lying. Is it the same register, or is it just lower? Okay, 2 registers encoding. Actually don't know. I could be lying here. It uses the register, but you can access half it. Yeah, I think that's right. Let me just making about something else. So we also have stack pointer, base pointer, source index, and destination index. These are all 8 bits. They don't have any 16 bits parts. Yeah, it should work exactly the same in x86. This is the idea of like decoding the 8086 itself. This is where this is the grandfather of like modern assemblies come from. Which is, useful for us to pass. Yes, thank you for helping us with that, TT. And conferring that I wasn't going nuts. I mean, I've already gone nuts, but I can't be incorrect and nuts at the same time. That's terrible. Okay, so the instruction encoding we're doing an immediate to register move with an effective address calculation. This instruction encoding is 11000011W. Like RAX, EAX, AX, AH, and AL are all the same registers, just access different bits. Yeah, that makes total sense. I think when I was writing my assembly to be able to write a decoder for this particular type of assembly instructions, that yes, every type of instruction worked. Hello, Mado. So that's good to know about. I assume RX is 64 bits, and because I know EX is extended AX, right? I assume RX is like, or RAX is 64 bit. I actually haven't seen that assembly instruction. Anyway, immediate to register move with effective address calculation. Yeah, cool. Thank you. You have a problem with the move operation when you try to do something like this. Okay, so you're not allowed to do this. Invalid. When you are doing an immediate to register move with a load operation, the assembly doesn't know if we want a 16-bit or 8 bits. With things like AX and AH, the letters tell us if it's 16-bit or 8 bits, but the base pointer plus 75, is this 8 bits or 16? We can't know. This is because base pointer plus 75 is an address calculation that tells us we are writing to and not how big. Yes, we're doing a bit of revision on assembly today, which will be ending, I think, shortly. Yeah, I've got to keep sharp on this, otherwise I'll forget it. How this resolves when writing assembly is you write either byte for 8 bits or the value word before the 16 bits. So okay, so I think you can put byte in a different place. I think I was at the time I was like, oh, I've got to put byte or word here. But this just tells us if it's a an 8-bit move or a 16-bit move. And I assume D word or Q word tell us if it's 32 or 64. You can think of this as a cast, then the assembler will set the W flag. So this tells us if it's a wide or not, based on that W flag. In our lovely instruction here. So this is just a Mad Doe's sake. This is 8086 assembly, so it's 16-bit assembly. But all assembly kind of comes from this particular instruction. Sorry, this particular CPU. Sign displacement. Sign displacement for move. When the assembly passes the instruction, it encodes everything as unsigned. If, say, you do move minus 12 into CX, the CPU doesn't care unless it's some kind of operation like addition, meaning when it's seeing minus 12, it sees just binary. In the registers, it doesn't care, meaning it's totally valid to print out as the wraparound value as 65,524. It's literally the same binary for now. Fucked up not having word mean word. Yeah, word is... I got super confused with word, you know, when I first studied this. You must be super intelligent, bro. Thank you, appreciate that. But on the contrary, unfortunately, it's one of the things I have to really study hard to understand this. Anyone can understand this, but I'm definitely not talented. So that's why This will be a long stream demonstrating how much work I have to put in to get to understand this and keep it in my mind. You can also do this with effective address calculation. So sign displacement. So we did this earlier with an effective address calculation. This can be a negative, but this will effectively translate to this in binary because it's the same binary code. This is a sign displacement extension, which we talked about, which is talked about in the manual. You just make the 16-bit number and treat it as a unsigned number, meaning that minus 37 turns into 65,499. These are the same operations. Yeah, like I said, the CPU doesn't care unless it's some kind of operation like add, subtract, multiplication, all that kind of stuff. Alright, accumulator to memory move. Accumulator to memory move. These are special direct address type instructions that have their own encoding only if you're using the AX register. Yeah, this is because the AX register stands for accumulator. So this is an accumulator memory move. The load where AX is first is encoded like this. And when you're doing a store, when AX is second, it's encoded like that. And again, the W is just for wide operations. These operations do exactly the same thing, but are encoded differently. So yeah, they do the same thing as you with an immediate, with a direct address lookup. Yeah. What does move allow you to? What does move allow you to do? What does move allow you to do? A load effective address in the same instruction. Oh, what does a move allow you to do? A load effective address in the same instruction. If we look back at earlier, is this what you mean? Yeah, you can do a load effective address in a move operation. But yeah, I don't quite get the question. I'm not sure if you're talking about a load effective address in like the register or something. Yeah, so if I misunderstood, let me know and I can try again. Okay, so we're gonna speed run this one because this is a pretty similar. So if you understand move, you can basically understand add, sub, and compare for free. This is why there's only one note on this particularly, because it's basically the same instruction with different encoding. It follows the same rules. In 8086, well, in 8086 at least, right? I don't know really. x86-64 assembly would look like. But anyway, in 8086, all the way up to x64, the patterns of this are consistent. So according to my notes, I was correct. Throughout the whole instruction set are pretty similar, meaning that when you want to do an operation, sometimes you don't have to do a move at all. You can actually bake in your move memory access into whatever memory access you are doing. In non-8086 instructions, to do an addition, you might have to write things like this. So we move the base pointer register into AX, which would actually be a direct address lookup, I think. But anyway, and then we move something from base pointer +2 into BX, and then we do an add AX, comma BX. So then we would have the value in AX, whatever the value of this addition was. However, we might do something different. Say, however, we might want to do something different. Let's say we just wanted to do an addition. If we want to use bx for something and we want to use bx for something else, or we wanted to keep bx with another piece of data that's already, yeah, it's already used, you know, effectively. The nice thing with add instructions is the encoding is pretty much exactly the same as move instructions. So you can encode anything you want in the source place, meaning that you can do this. So we move base pointer into the AX, and then we do an effective address calculation like we did here, but instead of using a separate register, we then just do the addition straight out of that piece of memory. This skips the second move we added. The nice thing indeed. As in both. Let me read that again. So, what does a move allow you to do a load effective address in the same instruction as in both actual move and arithmetic in one operation? Yeah, it's part of the load effective address is part of the move operation. Otherwise, it can't figure out exactly what the source and destination are. So it's not like we have to do a separate calculation for the load effective address. Well, the CPU will have to do other things. Did I write that? Hang on. Yes. Nice the thing. Thank you. The nice. Yeah, I just got it. Thank you, Omega Killer. Okay, so let's continue. The only difference is that the opcode at the beginning of the instruction, okay, which is this, right? Same as MOV. This is a very important idea. This extends beyond add, but you have sub, compare, all have the same idea. There's more than that though. This means that when you are writing a decoder for add, sum, and add, you can reuse the same idea across the same instructions. Sum with, I want to say sum with, add the thing, the thing with, I'll just save that. Add, compare, and sub the immediate instructions like immediate to register move with an effective address calculation, which has a second byte containing 00, which, if I open up that, this will be 00 for the move operator. For this particular, it'll be and then whatever the effective address calculation is, like 110 for base pointer. These instructions. Oh no, add. Sorry, add is that. My bad. I think compare. If I remember, move is 100 effectively. Add is 00. Sub is 101, and compare is 111. When we look at the second byte, and if we can see that, I think if we look at the if we go to add, we'll actually see it for a. Get out of the way. Where is the thing I'm looking for? This 00, right? Oh no, wait, that's not. That's where is this? I wanna. If I look at add though, it'll tell me. Okay, there it is. Okay, that's what I'm looking for. So it's 000. If I go back to the other thing, the reg, instead of okay, so there we go, 000. Right, so it is 000 for move. I thought it was right. 000, and then add with carry, and then where's the subtract 101? This allows us to like decode the instructions faster because we can actually just like skip. And you'll find as well that the immediate from register, which is what we just did here. This thing is immediate to register, I think, right? Has the same instruction coding, you know, 10000 SW, and if we look at this, 10000 SW. The only thing that's different is this middle bit. These middle 3 bits, I should say. So that's what I'm talking about here. So you got to be careful. This isn't true for move though. This is only true for these 3. We don't have this SW instruction thing. Anyway, which these instructions have the same opcode. You know, that's what I just said. 10s SW. But the way you tell the opcode apart is the second byte encoding pattern. If you look at the register to move operations, and effective address calculations, take the knowledge and notice that you have the same instructions for add, subtract, and compare. All of the same 3 bytes, but have a different opcode. So the opcode is the first byte instruction. So it's a different so we're in subtract, right? Different opcode, same setup as the move. Disp low, disp high. Mod reg rm, D and W, which we talked about earlier when we did a move operation. Same dealio. So yeah, once you know how this decodes, then you can work out how at the very least add, subtract, and compare. And there's more. There's actually much more. Let's compare. And again, this is the middle bit as well. It's different. But this is once you start to figure this out, it kind of all starts to cascade. All right, last one. We have conditional jumps, which is very, very simple. Conditional jumps have you have instructions like Z, N, W. Why am I saying W? N, Z. J, N, Z. I completely said the wrong 3 letters. Jumps to somewhere in the code. These prefix J to a jump and LE for less than. This type of instruction would be JLE. It's best to look at the instruction manual to see what the condition is. To decode this, you just look at the opcode and the 8-bit displacement. It's very simple to decode, unlike everything else. There are no conditional jumps. There are no conditional jumps, and they work different to JZ. Oh, I'm trying to say why am I saying that? I'm literally reading the wrong word. There are non-conditional jumps, and they work differently to. Okay, I just completely lost the plot then. So there are conditional jumps and there are non-conditional jumps. They work differently. Cool. And I'll just put like a random instruction in there. But where are these? These are in. There you go. If you want to decode them, very simple. They have their own binary opcode that fills up a full 8-bit a full byte, and then you just have to read the next byte over. Anyway, so that is my revision on assembly done, which is nice. What I need to do next, let's see. So we've done 1 hour and 40 minutes of basically revision on assembly. I think we've done enough revision. I think I'll keep this up there. I thought that JLE was jump less than or equal to be honest. Let's have a look. So you said jump was less than or equal to not greater. Okay, so what did I say? Okay, so the jump J prefix is LE for less than. Okay, or equal. Yes, you were right. I made a mistake. Thank you for pointing that out. Or equal. This type of instruction would be called JLE. Yes, you were correct. Good job we got the manual there for us. Alright, so hopefully that wasn't too strenuous for anyone. Nice bit of revision done. I'm just going to restore this a little bit while I think about what we're going to do. To study. I think I should change this briefly to this. So we should have everything kind of rocking and rolling. Okay, so the camera is not following the player, which means we have a free floating camera. Where is the camera? Oh, no, it's lower than this. It's lower than this. Okay, so that should be the same as it before. Yep. All right. And then we crash into stuff again, and the lights following is good. Okay. Crash noise. We did that yesterday. Okay, so despite us studying assembly. Doing revision on assembly. Okay, so I need to get my notes up from yesterday. So this is what we talked about yesterday. And hopefully this will tell us what we're going to study. Alright. So this is the last thing I did. So we need to be able to forward out an object to run when they collide so they can do something. You cannot access the body interface in the contact listener. The contact listener, I think, is handled. Okay, yeah. So I had more thoughts about this after the stream. So I think if we look at, so we're not going to do this coding yet, but the physics code. We have a my listener which tells us what type of instruction does what. What type of... a contact happens and then we get two bodies in. And then based on basically a reinterpret cast, we can actually do something with that body. Now, the problem is... there's two problems. One, the body code will be kind of stuck in here. And just kind of live. Which I don't think is very good. And two, we don't know what body it is. So we're assuming there's always the player at body 1, right? And if we reinterpret cast something that doesn't technically point to that piece of data, but the 16-bit pointer, 16-bit flipneck, 64 pointer, This will be UB, and I don't know what would end up happening. We would end up dereferencing to something to a function that doesn't exist. Don't know what would happen. So that is what we're going to be working on later. And I think my idea was make the contact listener do more than just listen, right? I was thinking, right, well maybe we can beef this guy up a bit and kind of have it handle a bit more than just figuring out what contact does what. Now the we've got to be careful because that runs path, like multiple threads access that function. You should technically use unique PTR for storing pointers as integer values. That would be cool, but actually, what do you use? Yeah, it uses standard 64. I'm kind of just going off the library. I thought it was standard 64. Yeah, the library is just doing it this way. It's a bit screwy to be honest. But that's C++ for you. You can pretty much do whatever you want. So I'm gonna kind of stick with this for now. I mean, maybe we could do a unique. Let's have a go. Uint ptrt. Now I believe this is basically the same guy. Yeah, I think this will help me out. Assuming that I don't want to make it a random implicit convert, so I'm just going to check to make sure these are the same values. Because you are right, I think when it comes to the define, yeah, they're the same. Where does unique pointer t come from? That's not in the same place, as far as I can tell. It's in VA D defs. What? Let's have a look. That just might be just in the standard, and I'm just kind of a bit. It's in standard, apparently, according to the AI bot. It doesn't really matter. It's optionally defined in C++. Okay, so I was just making sure it wasn't randomly. I was making sure it wasn't like a Visual Studio exclusive thing or something. All right, cool. Yeah, we'll do with that. I think it's gonna be easier to like for me in the future and other programmers, but potentially to understand that that's not a number. Yeah, I'm just I mean, it doesn't matter if you're running in 16-bit mode. By the way, unsigned integer pointer type are not unique. It's I see, it works the same as size t. Okay, thank you. Got ya. Now, like I said, I was just making sure that I wasn't just having a MSVC exclusive here, but it's not. Okay, so there is this idea of studying what I want to find. If I could find this idea in the wild, a common pattern is to create, or in this code base, to create a listener that casts get user data to an object, and then the framework, and then forwards the call to a handler specific for that game object. Now, handler, what I'm thinking about doing is basically writing the handler here. Like beefing this up a bit, just having a big handler here. And based on the object type, I would need like some runtime type information, I think. To figure out exactly what type I'm messing with. So I think it's going to benefit me to study some runtime type information, fundamentals, rather than just go straight into graphics theory. So I can actually figure out how to do this when we get around to it. Because we need to know what object type it is to be able to do anything at all. And yeah, make my contact listener a BFM motherfucker that does a lot more. Yeah, I think that's what I'm gonna do. So this might be a bit C++ heavy. So for those, I know someone's a Zig programmer who's watching. So now I've got to find a bit of a resource that like goes into runtime type information a little bit deeper than just. It just tells you what type it is, like an AI response. You know, we've got to know a bit more, because that's what we need to know at runtime. What the hell this is? So let's figure this out. How are we going to study this? And hopefully get an example of how runtime type information works. So Geeks for Geeks is often quite a good website. Yeah, but this is too generic. It just tells me up and down cast because I already have a note on this. I need like an example of like what's going on here. Like, because there's other stuff as well I need to worry about with this. There's like serializing data out of a file. Like, for example, saving, you know, in the future, saving progress and like having a level editor, for example. You know, it would be pretty bad level editor if I had a. If I had you know, you could design your level and then it doesn't save your progress of what you've designed. So that's my. Let's just see. So this might be a. Yeah, what do I need to do here? Is it reflection? So you just have to bear with me a little bit to figure out what is what. I know C++ doesn't have reflection unless you use like the newest standard on the newest compilers. And even then I think it's static. Anyway. What do I need to do? So yeah, this is just going to be me searching information. Yeah, C++26 has reflection. Yeah, it's only compile time, that's the thing. So we're gonna figure out this a bit. So the first task, okay, so first task for everyone, just so you're going to figure out, so you can follow along a bit. First, we're going to figure out what I need to know, and then I'm going to actually study what I don't know, right? The first task is figuring out, okay, so with this particular problem set that we have to solve here, we've got to figure out what object type it is based on just a random cast. Like, how do we do this in a way that makes sense? Now, I could just say, maybe I can avoid this, hang on. Oh yeah, we're finally getting enum to string. What the hell? That would simplify a lot of my resource code. There's a bunch of, where did I put it? I must have got rid of it all actually. But yeah, there's like a bunch of code. I had to do a bunch of stupid Yeah, we need like pointer to variant maybe. It's I've got to think about this kind of smart and then study what I need to know. Okay, so there's a couple of ways of doing this, I think. Generally, if every entity, so if every entity, sorry, every rigid body has an entity is just a generic entity type, then we can pull out things we need based on its indices into other arrays and stuff. Array slash, I don't know, structs or whatever. I'd say arrays all structs, right? Because it's not like they can be mutually exclusive. And or to access data and functions, right? So it's a bit wider. So if that, or for example, the reason I'm saying that is because I already have almost that. The only thing that is legit kind of by itself is player. But if I had a way to take this object and go, oh, it's a player. This is just an entity. Is player is true. Okay, so let me cast. Then instead of like doing what I want to talk about is we go pointers 1. Entity, right? Oh, we don't have it here. Okay. So entities in. Oops, sorry, that was me. Where did I stick it? I think it's in scene. Okay. Right, so then I can do something like what's an entity? Entity index. Go back. It's a scene. Oh yeah, okay, so at the very simple I can go something like, where's physics gone? Alright, I'm gonna get rid of this for a minute. Do this. I think that's the thing I was missing. Is player, for example. Then I can go, okay, based on that, we can go into. So if true, this is just an example, right? Then, alright, so this is the player. Then we take our pointer again. I should just save this to something, I guess, instead. Let me just assign this to something. needs to be a pointer. And we have current entity, so we're just going to simplify our code a bit. Okay. Then we do something like entity index, and then we do something with this. I don't know what we would do, but we then go into a index, and then do something with something, right? So with the player object itself, how do we do this in here? We actually just use the object player. But what I'm thinking about is, like, instead of having a generic, like a separate object, we can bind everything into entity, right? And then if you want to have a player struct like we do here, we need to then refer to this somehow through the entity index. So somehow we don't have it yet. So somehow refer to a player object, right? Question. I'm gonna put it here, and then effectively, then we have a, you know, player dot do something after that, right? Based on some kind of index lookup with this index thing. That's what I'm thinking anyway. Something like that. Something like use this index to do something, look up something, and then we can find it. Pointer to function that returns an entity. Yeah, we could do something like that. It's some kind of, like, that's what we're gonna have to try and figure out. So I'm gonna try and do a bit of studying before this point, and then we'll tackle this. I might do a bit more coding today because I'm feeling a bit more coding. I'm going to head to the loo. So I'm just gonna put a BRB up. So I'll be right back, guys. Just going to the loo. Alright. Alright, see you in a sec. I'll leave the music on though. Might be worth setting up a BRB scene in OBS. Yeah, this is probably better than just setting up a random. Thingamajiggy. You're not wrong there. Alright, there's a lot of things I want to do that are kind of... This was a bit of a spare of the moment thing. So, alright, let's see. Alright, I'll put this in comments. Okay, so what do I want to do then? So we have a player object which is separate from just generic entity. And right now we have a player object that kind of just is floating around in the main. So you might want to figure out a way. So I'm honestly tempted to, let's put this back on, to look at like an actual entity management system, like, and kind of just like figure out what's going on. Oh no, I saw the word modern in C++. That's not a good sign for looking at other people's code. It's data-oriented design though, at least. Maybe it might be worth... Obviously, we would want to use like 1% of this, if that. Because I don't want to add like a whole package manager. Sorry, a whole new library just for this particular type of thing. So, but it's going to be useful, I think, maybe to go through this to figure out exactly how we would want to basically build up this runtime type information in a real project, so we can figure out what's what based on things. I think we're going to do it via an index. But even with that index, we need to know exactly what that index is going to do, because we've moved the problem a little bit downstream, but we still have the same problem, right? When it comes to figuring out the physics, right? We have a... just a generic index. And we don't really have a way to figure out what that is based on that alone. The only thing that's doing for us in main, at least, is it's helping us to figure out when we loop through a list of entities, we just pull out the entity index that then gets pushed into this array. So we have like super homogeneous data, which everything's just kind of like sits. And the only way like this array and this array, which is a different thing, they have the same index. Now that's fine for like data that's just in a contiguous array or whatever. But the problem I'm having is not that. It's I kind of want to fix this real quick. Yeah, do you mind? Do people mind bearing with me just for a minute? Because I kind of do want to fix this. This is like a non-issue. I've just spotted something. I just want to get rid of this. So C mat falls. Player matrix. So we're going to just store some extra data here and kind of just do M31 is this dupe, and M30 is that. It's not that important, but that should, I think, move things in the right direction without having random access in our data, because we're still going to have sequential write access. Let's just see if that works. Oh, we've got a bunch of... Yeah, okay, so the code I kind of left around, lying around. Oh my goodness, this is a... Why doesn't it know what physics is? Okay, so let me fix this as well. This is I can put physics in here. Physics / physics. I don't actually need the argument, because we only want one physics guy. Go away. Yeah, so we actually want to get rid of all this. Any instance of physics. And get rid of this. Okay, so get rid. Why are you complaining? So what I'm doing here, sorry, I'm a bit far away from the mic. Is I'm not passing around the physics object because I don't need to. It just kind of makes things clumsy. So there we go. And we delete this, this, and we should be... Why are you complaining there? Okay, still not done though. Okay, so shutdown still needs to be fixed. And every instance of physics now can be replaced with the... So when is it actually needed here? Physics instance. Okay, yeah, that's correct. Alright, yeah, those two are fine. Sounds good. Alright. Okay, so IntelliSense, I don't know what IntelliSense is trying to tell me here. Scene still exists. I don't know why it's getting confused. Okay, so it doesn't know what JPH is. Okay, so I can actually extract that out of the physics. I don't need to include literally everything in here. Right. So I'm going to try and get... I'm going to copy all this out just for a minute and then delete things one at a time, I think. So what I'm trying to do here is in scene, just trying to get around this use, but I think it's literally this. If I just get rid of all these, I think it knows what this is, right? Okay, RH real. That's all I really need to know, I think. Yeah, okay, so I think that's fixed that. Everything was kind of broken for that reason. Why is debug scene complaining now? Okay, so no, we didn't actually get that right. Is the job physics real anyway? Oh, hi. By the way, you could store entity index directly in user data instead of doing some extra pointer lookup. Yeah, that's effectively what I'm going to do. It's just we're going to figure out exactly, do I need the actual object? This is why you use sane LSP with Clang D. IntelliSense is known to be weird. Yeah, I don't understand IntelliSense. I don't think anyone does anymore. It's the true AI that escaped the box. It where is... Right, so I need to figure out this. I don't want to include literally everything here because it's a waste. And this is... Actually, let's actually go to the file. Jolt physics maths, okay. So, maths / real should have everything in it for this, at the very least. Vec4, which I hope is in real. I mean, it doesn't really matter if it isn't. No, I don't think it's not going to know what to do, is it? Vec4. And what else do we use? We use mat4. I bet that's the same. Mat4. No? Yes. Cool. And we have vec4, mat4. This is this thing. Alright, cool. What was the other syntax error that we got? Oh, we need vec3. This doesn't exist. You literally said it did. Oh my goodness. What is happening? Oh my goodness. But you're defined in real. I'm so lost. Ugh. I think it said at some point when I was reading the documentation that you need to include jolt.h. But I feel like that's like super heavyweight. Like it includes literally everything. Yeah, well. Ah, it's map 4-4. Okay. Maybe I can get away with this. Let's pray. Okay, what are the other syntax? I'll look at the other syntax errors. Oh. Right, okay, so there's more here. Right, screw it, I'll just include jolt. Whatever. There's more here. I forgot about this completely. Okay, so at the very least that should work. IntelliSense doesn't even use the MSVC compiler internally. Wow. I bet it uses Clang. Keep up with the good work, bruh. I appreciate that, dude. Thank you for joining us, New Wave Dreams. Hope you have a good day, whatever you're up to. IntelliSense will see a 4 and complain about it being out of bounds. Read randomly on... Really? Why would it complain about that? That's crazy. Is that because the integer isn't there? Oh, it's some legacy stuff? Wow, okay, interesting. The more you know, eh? IntelliSense being mental. Okay, dokie. As the boss music for Sonic 1 comes in, let's figure this. Let's build and see what... See what the other... Oh, I know what the errors are going to be. You're using physics and I don't have to. It's going to say that. And for the demo scene, I don't need that either. And down here for shutdown, because we've got a singleton pattern. And what are you talking about? Okay, so body creation settings. Let's do that again, hang on. Body, okay, it's body slash body creation settings. So I'll copy that. And your body slash dot h. We build again. To be honest, MSVC's compiler is basically dead right now. They haven't worked on it. They haven't worked on any of the 26 stuff, really? Damn. So TT said, I have 5 array accesses at the same I in a row. Right, complains 2 of them. I think I've seen that maybe. Maybe I haven't, maybe I have, but it feels like I've seen that before. Where if you reuse something too often, it kind of goes crazy. Oh, it's physics, then body creation settings, S. Alright, please just know what that is now. Okay, we're getting there. Oh, yeah. Okay, that right, just doubled up there. Right. Right, okay, yep, everything's fine. Yeah, this is something that IntelliSense keeps telling me is an issue. It says this is uninitialized data. It's like it's literally initialized here. There will never be a situation where this for loop is never ran. And if you're sending me data that doesn't exist, then this will just break. Like everything will break apart. Well, whatever. There's a bunch of stuff like that, but I can't really claim much because that maybe I'm writing it in a way that compilers, no compiler could see what I'm trying to do. Right, fantastic. So we should see my update. Let's see. Let's see. Nope. Right, okay, so that didn't do anything at all. But I need to maybe look at... So what I'm trying to do is just move that duck down a little bit, but it might not be possible the way I'm trying to do it without Yeah, so I'm just trying to add some transition before we then... okay. Yeah, that's never going to work, is it? Okay. There we go. Actually assign the changes we made, eh? Often a good idea. Yeah, okay, so now we don't have the random access reads when we only want to do a write, so now everything's kind of a little bit nicer for the player. It's a minor thing. I wanted to clean that up though. Fortunately, there's a bunch of other stuff I needed to fix. So, what do we want to do then? I kind of want to not immediately jump back into coding. Okay, so we have end. Now, is there example code? Because that's going to be more useful, I think, to figure out exactly how this works. And then, what's this? What I'm trying to figure out is basically, if I can figure out how this works, then I can figure out like ideas that might be useful in my case. What is this? Is this not his documentation? Okay, so this is just a meta. Anyway, okay, so yeah, it's just a bunch of links to tell you what that means, okay? Yeah, because we need to figure out a system to do this. Okay, so a code example. It says position and velocity. Okay. Why is modern C++ syntax so ugly? Sorry, I'm being a bit of a hater right now. Okay, so function callbacks. This is view each. Oh, I see. This is just a lambda. Okay, I thought this was some standard template thing. I was like, oh my goodness. Doing some weird standard template stuff, but no, it's a part of this, I think. Which I believe is part of the entity code. Okay. I don't know. This is completely irrelevant. We don't really want to do this, I don't think. Use extended callbacks. In this view guy. Oh, this is the update. Okay. I still will stick for this for a minute because it is kind of important that I figure out what I want to do. And if I see stuff that I don't want to do, then it's kind of like nice, easier to use. So this is going to take, I believe, what, 3 lambdas, and we can do something in these lambdas based on, I forgot what this is called, particular automatic list thing, so we can then extract out what we need. Very true. Yeah, my code is ugly as well, yeah, admittedly. Everything's still in main. Modern C++ though, I will still be a hater. Not necessarily this, like this person's code. When modern C++ goes full modern mode, when you have to use every single new feature, I will call your code ugly, regardless of what I've written. I'll be a bit of a hater there. Yeah, but yeah, you can call my code ugly as well. I'll 100% accept that. There is, okay, a bit of a side tangent. Programmers often have this like not often. Elegance, right? People talk about elegance when it comes to coding so much that I would rather have ugly code that's more obvious than elegant code, in my opinion. That's just a preference, though. In my opinion, again, this is just an opinion. Some programmers take the word elegance too far and, try to make code that's just like all in one line because it's the most elegant code ever. The least amount of lines of code you can express an idea, the better, because elegance equals brevity, I think. For a lot of people, I just think I would literally rather have like super clunky looking code that's just super easy to read. And elegant people might even say that, they might even argue that, well, if you're good at C++, you can read my code fine. Which is, it's an argument, but yeah, I would rather read C code than, air quotes elegant 26 C++ with every feature enabled. Anyway. Yeah, it is. Yeah, this is C++ 17, 100%. I do recognize this as 17. Structure bindings. That's the one. Structure bindings. I just forgot what they're called. No, the reason I was complaining earlier is I thought view was some kind of a new C++ feature. I'm not calling this particular code. Because I was a mistake. I was mistaken. I thought this was something C++ standard, which it isn't. So yeah, this is me prematurely complaining and just bringing up the idea of elegance. Anyway, so I'm just reading this. When I say this is not what I want to be able to do is access these objects. Maybe this is what I want, though. If I hypothetically had this, could I just do a reinterpret cast on a pointer? That's the one I was thinking of, yeah. Standard range views for each, yeah. That's what I was thinking. I don't know why we just can't use for loops. I don't know why we need these views and stuff like that. I don't know. There's probably a good reason behind it. I'm not saying that I'm smarter than all the C++ people. But anyway, yeah, I thought it was views because I saw the word view. That's why I went, meh. Alright, so what I'm looking for is... Have you seen yes, I worked on pre-C++ code, pre-C++ 11 code. What ended up happening in that situation at work is we had a bunch of code that was written like, standard template stuff equivalent. So we had to write a bunch of standard template stuff. Not gonna lie, sometimes standard algorithm is kind of nice. Oh yeah, I'm not saying all the standard is bad. In fact, for many years, I at my work I replaced a bunch of stuff with standard template stuff, with the standard template library because we had a bunch of leftovers when we moved from C++. We had a weird compiler that was like C++ 98/11, but it wasn't really 11. It barely had any 11 features in it. But then we upgraded. It was like GCC version like 4, but like an early version of 4. And then we went basically from 4 to 8 like instantly. And at that point, I started to replace a bunch of like old stuff that we had written in the past with new standard template stuff. Because it was just like, you know, we don't need this anymore, and it needs to be maintained if it's like written. And that's why we started to do that. Yeah, it was yeah, GCC I think had this like versioning thing for a while in version 4. Like version 4 like lasted forever. And then they just kind of dropped it and went like back to normal versioning. Like it was like version 4.1.72 or something. It was like a long, it's like a randomly long versioning number, and then he completely changed it to 8. That's why we went to 8 very quickly, because it was after they stopped using like version 4 dots, like a bunch of dots after the 4. I can't remember. It's a while ago. Like it was a DevOps thing, so I wasn't in charge of it. We just got moved up. Once all the libraries had been compiled that we were using. Oh, hi. How you doing, dude? Good to see you again. Yeah, enough as might be a bike shed thing that I'm yapping about right now. Yeah, so let's look at the source code a little bit. This might be too complicated though, for me to just like randomly know what's going on. Let's see the documentation actually before we do this. Oops. Is there actual... Sometimes there's like a documentation page. There's a... Okay, cool. Okay. Alright. What have we got? Alright, I think we're getting the same music again. So I'm just going to refresh the playlist. Yeah, just to put it in perspective, we had compilers that didn't know what const expr was at all. Like, and I was working on that last year. Like, if you type the word const expr into C++, it wouldn't know what you're doing. It would just give you a red underlined error saying undefined const expr. Okay, so what are we looking at? C++ 11 const expr is pretty limited. Yes, it was. Yeah. But even then, like, it didn't exist. The compilers we had were technically C++ 11, but didn't know what const expr was. So that just tells you what the C++ 11 state of the compiler I was working with had at that time. Yeah, I use it pretty much ever as well. Well, when I can, at least. I don't really have any need for it, but if I can get away with typing const expr, I will over const. I mean, with static variables as well, it's pretty much a guarantee that you can use const expr most of the time. Yeah, it's fantastic. Now you have like returns, like functions are now context, like more functions than you'd expect. Some containers are context bearers. It's fantastic. It's very nice. So what I'm looking for here is Rust versus C++. They both should exist, but I don't really have strong opinions on either. I just write code as simply as I can, and there we go. Okay, so let's read this. End comes with a bunch of core functionalities mostly used by other libraries. Many of the tools are useful in everyday work, therefore describing them as not relevant in the wheel. Oh, not to reinvent the wheel. Okay, sorry, I kind of read that all weird then. Any as in type. Okay, so n offers any type. It may seem redundant in C++ 11 with standard any, but it's not, hopefully. First of all, the type any is a contra reference, standard type info. What is this actually? It's kind of interesting. I'm gonna kind of park that for a minute. An implementation defined class that is not something anyone wants to see in software. Furthermore, there is no way to bind the type system of the library, and therefore with integrated real-time type information support. The any type is an API similar to its famous counterpart. Mainly, this class serves as the same purpose of being an opaque container of any type value. I don't know what it's referring to with this famous counterpart stuff. I talked about this earlier. Sounds like there's an entity component system rival. Instances also minimize the number of allocations by relying on well-known techniques called small buffer optimizations. Nice. And a fake vtable. Create an object of any type. Okay, so we have empty container, a container of ints. Sure. No, I've literally, it's the first time I've heard of standard any. But this seems interesting though. I thought, yeah, as a const reference, I don't know, is it a const reference auto type? I've literally no idea. I mean, I use auto every now and again, but I don't think that's what any is. Alternatively, the make any function serves the same purpose. It requires to also be explicit about the type and does not support taking ownership. Okay. In all cases, the any class takes. Okay. Should I read all this? So I think this is for strings. No, it's just small string optimization. Small buffer optimization. What I'm interested in is how does it... You know what, I'm just kind of... I don't think it's going to be that useful. Let me think. All I'm going to do is learn how ent works and not know how to fix my problem, I think. Which may be useful in the long run. But I want to solve my problem, not know what ent does. So the goal of this was to figure out how ent works, but what I really need to figure out is how someone might use Jolt's physics engine for the collision detection library. So, sorry, for a contact listener. Mm-hmm. So what I'm going to do is open up Jolt and just see if I've got lucky here and it's got something in its own project that kind of does that. Because I need to figure out exactly how it would just nice to see an example before I dive into things, right? That's the only reason I'm not immediately jumping down this and trying to figure this out like instantly. Oops. So, contact listener. That's what we're interested in finding out. Character test. Yeah, so this is a contact listener. And it takes in the bodies. Let's see. So when added, persisted is also the same. It gets the ID and then it does a Yeah, it just says the same thing twice by the looks of things. This is kind of what I do, but it kind of want to do, but I want it super general rather than just like it happens for one thing. I assume this is a body ID, right? So it looks like you can compare body IDs, which might be actually really useful for our case. Okay, let's look at other things. Yeah, I used to be pretty hot on the C++ standard stuff. I just I definitely fell off over the last year because I haven't been listening to C++ weekly like I used to. That was a great thing to listen to. Like when I was like having a long compilation session. Yeah, at work I would just stick on like a random C++ weekly thing. And learn some random C++ standard thing that you had to try and keep up to date with the industry or whatever. Some of the stuff is good. I definitely learned how to use context spare properly. But some of the stuff is like completely useless. Well, useless in the sense I never used it. But I kind of miss sitting there just watching C++ weekly videos. Calling it work. Alright, let's have a look at this. Alright, yeah, so I'm just going to look up all the contact listener. Character contact listener, is that? Huh. Oh, this is for a virtual character. Okay, so the virtual character does something completely not what we're interested in. I love this song. Alright, so let's have a look. If only I could match the statement like Rust and C++. Oh, match statements. Okay, yeah. Oh, I vaguely remember what those are. You got pushed back to C++ 29. I know it seems... This may be slander, but At what point are we going to stop with the C++ standards? Or we just say it's done, we don't need any more? Or at least slow it down. Like, does C++ need every feature that every other language has? Not that match statements are particularly bad, by the way. I just thought in the long term. You know, is there a plan to be like, all right, yeah, we have every feature of every language possible. We don't need to go any further. I guess the ultimate goal was to make everything compile time. Yeah, there'll be a new C++ standard to the heat death of the universe. Yeah, I mean there'll be new technology to implement as time goes on for sure. But I just think like, damn. You know, at what point are you going to say we got it right, dude? I'm just trying to find something that's a bit okay. Vehicles will be a good one. We got it right, guys. We don't need to go any further. Congrats. Okay, no. Well, I'm just gonna go through the headers actually. That'll tell me what contains what. If you could create your own programming language, what would that be like? Probably a mess, but you know, ideally, if I you know, if I had the skills and knew that kind of stuff outside of what I want it to be, it would be soft body listener. I think that's different, right? Wow, that's loud. I think I just got blasted then. It would be close to. It would use structure of arrays. It would allow you to do things that. It would just be data-oriented design language. It would be very simple. And because I don't think we need, well, in my opinion, right? I don't think we need every single language feature in in one language. You know, sometimes you can just do things one way and it just works that way. So it would be a very stripped down kind of data-oriented design like language. I couldn't tell you exactly what that would look like because I haven't really thought about it. Yeah, Escape plus plus maybe we would call it. Alright, so let's keep looking. Why is test? I keep seeing this over and over again. Just making sure this doesn't have like a contact listener or something. So it has virtual classes that do contact listening, but I just want to get this right because I don't have to rewrite it like 20 times to get, you know, I'm probably going to have to do that, it looks like, by the looks of things. Alright, let's mock up something then. I'm going to move to dev. I'm going to do some development instead of like studying. Alright, so let's close physics for a minute because it's kind of awkward to have two Visual Studio with more than two. So I'm going to mock up some kind of like idea. And this one, right? And I'm just going to hit the blue again. So, you know the drills. My terrible BRB. Yeah, so I'll be right back, guys. Yo. I get XP every time I write. Wait. Or is that just... No, is that just a coincidence? Well, it depends if your typing speed is what you're interested in, I guess. You could say, yeah. You're leveling up your typing speed at the very least. Oh. Oh, okay. Right. Didn't realize. You... Message redacted. Okay, so what do I want to do with this? Yeah, so let's prototype some kind of idea, right? I'll stick this somewhere else. I'll stick this in, see if I remember this though. Let's stick this in mini audio, I guess. Comment it out. Oh, yeah, you do actually. I think if you like the live stream, you get more XP as well. I think if you interact positively with the live stream, you get more XP. So you get I think if you react with the heart thing, you get XP if you chat. You like the live stream, I think, and you get a load of XP if you donate to the live stream. That's the most. When I've donated to live streams, I'm often to smaller live streams at least. I'm often the most XP'd person, the biggest fan. There you go. Now you're number 3 fan. There you go. According to the things. Yeah. So there you go. You get your crown. That's pretty much how it works at least. All right. So let's design something. Right. Okay. So. Well, hey. Congrats, number 3 fan. But it's also like your length. The longer you watch the live stream for as well is you accrue like 25 XP every X amount of time. So you'll often, unless you donate, there's if someone's been here for like 9 hours or something like that, it's unlikely that you'll overtake them in XP. Anyway, this is like the most bike shed thing of all time. I don't mind talking about it. It's just you know, John Vulkan, and will beat me up if I don't keep coding. Right, so so entity index, I guess. So here's the thing, I need to figure out a struct. Yeah, and yeah, thanks for actually, you know, I always, I feel like I don't do this enough, but yeah, thanks for everyone who's talking and you know, interacts with me while I slug this out. You know what I'm saying? It's I very much appreciated stuff. It's I think I've talked about this before in the last live stream, but I expected me to be talking to myself for like hours, because now I'm doing like I've wanted to do like longer live streams, and now I'm actually doing it. Which is, you know, it's kind of cool. Let's do pause 3, right? Something like that. All right, so now we need to figure out how this guy. So currently we have a bool is player. Yeah, it's like a joke, right? Like John Nintendo is the final boss of Nintendo. John Vulkan is the final boss of Vulkan. So he comes and beats you up if you don't do very well with your Vulkan. It's the final boss, you see. He is the Vulkan that we all refer to. It's something that Gen Z people say that I kind of half understand. So, so I might be completely butchering what you're actually supposed to say. Alright, so 0 and then true. I should at least do the dot entity index type because that is actually really nice. It's been in C forever, but now in C++. Hooray. I forgot what this is called. This is a nice feature though. And then I'll write a for loop for the rest because it's just going to be easier. So this is how I set things up in my code. Let's go with, I don't know, 5. And we're going to do a pushback. Yeah, John Pork. Yeah, I think that's where it's come from. I think it's a John Pork thing. Mister, we don't need more features. Likes new features. I know. Oh my goodness. I'm a betrayer. The reason I like this feature is because I've written structs in the past like this where you do initialize a list kind of thing, and oh my goodness, it's it got so confusing so quick. All right, so this is the current setup, and effectively I need to be able to go, okay, entity 0 equals player, therefore cast to player. Alright, so let's figure this out. Yeah, also at lunchtime as well. I said this last time, but you know, if you have like a cool vid, like that we can watch, feel free to let me know. If it's you get double bonus points if you get if it's something to do with programming, because I want to be productive. Maximum productivity. Anyway, but that's in 45 minutes, so we got a bit of time. Gonna do some work before then. Okay, so therefore, right. So how do we want to do this? So, we could have, instead of like a random boolean, we could have a simple enum. It's like entity type or something. Now, we're not going to do what we did last time. That was a big disaster, but I don't know, tree, rock, lemon. I'm not going to try and categorize these. These are just going to be like an indicator of what the type is. And should put duck in there because we love ducks. Rubber ducks at least. Count. And instead of this thing, we then... So you just bake in the runtime type information based on an entity type. And... then we do player equals this. and it should resolve it. No, it won't resolve itself with dot that. Okay, so type alright, we'll just do a random, we'll just say tree for now. It doesn't need to be complicated. Okay, so then I can switch over. So let's just say I somehow get the entity data out from the body data. So this is the cast, right? I'm going to fake a cast here. So current entity. And this is going to be... Now, obviously, I can't really do this without kind of cheating. And just being like, oh, da da da. Alright, so then I go dot type. Oh, no. Yeah, no, current entity, sorry. I meant to do that. Then I do current entity dot type, and then let's see how this works. Oops. Case. Unfortunately, you can't do that for the other side because they're all out of whack. Break. Right, so let's try and do some casting though. So what I'm going to do is, we have a player object, right? Now, even if we have that, and we do some, what object is getting cast here? What is getting cast? You can actually do it on the other side if you start at the rightmost button. Oh, can you? Okay, I'll try that next time. Because I do like using that a lot. So we have an entity. We have, again, this is just like generic data that's come in. This is our fake cache. This would be the equivalent of, so body 1 dot get user data. Let me take that and cast this to entity. Right. That's the equivalent. That's like, this is the fake. We kind of faked it here, right? But now we need to do something with that. Once we figured out, all right, so this is definitely a player. Then we need to be like, do something with a player object that's relevant. You can also, you could have used control left to jump over words. You can also escape cancel multiple cursor, so you don't have to use the mouse. So control left. Oh, I'm pressing shift. I'm just so used to pressing shift. Right, okay. And you're also saying if I press, if I'm in this mode. Right, okay, that was escape. I didn't press the key. Nice. Yeah, I'll try and be a bit more keyboardy. Not that it matters, but okay, so we need a way to look up like objects. Right now, I'll play objects just sitting on the stack in main. I need to be able to access all my objects. I didn't even have a player object. Hang on. So I'm gonna put this in it. How do I do this in a way that makes sense? Alright, so I'm going to not have this in main because this is a bit bogus for a minute. Alright, so let's fake this. Okay, so this is a class. Contact listener thing, right? And then it's going to have a function called on contact. I'm just going to say. I'm going to use their syntax to represent this isn't mine. That has this in here. And I'm going to take a uint 64t index. Sorry. No. PTR. And I'm actually going to do this in cast properly. Pointer 1. Oh, just pointer. And what I'm going to do is when we go in here. Alright, so this is the threading world. Oh, physics engine, I guess. We have contact listener. So you're gonna have to bear with me for a minute, but oh, not correct. So this is a contact has happened, and what we're gonna do is we're gonna do a needless cast here, but it's kind of on purpose. 0, right? We're going to reinterpret cast that to a PTR underscore T. I'm going to wrap this up so I can do something else with it. Alright, so that's the address. Actually, I don't need to do this. Why are you complaining? Oh, it's inaccessible. I'm so used to using flipping structs. Alright, so when we take in this pointer, then we have to do this. Actually. So I'm going to take this pointer. We're going to reinterpret the cast this thing out of, so it's an entity star. Is that no? I don't think that's how it's done. Hang on. Yeah, because I want this to be as like simple but like realistic, if that makes sense. Saving 0.3 seconds to use the mouse is what programming is truly about. 100%, no doubt there. All right. Let's just see what they do. Right, so in my physics code, I'm taking our object and I'm, yeah, casting this right, like that. That's what I want to do. Because that's going to be more accurate. Because then I can check if it's valid. Oh, yeah, semicolon. Okay, so do I have assert? No. Include C assert. And then we're just going to go. This has to be false. There we go. for it to be triggered. Okay, so that's more accurate. And in theory, what I'm going to do is just make sure that I've written stuff that makes sense. So I'm just going to standard count. Because this is isolated, it's not in main. If I'm giving myself too much information here, this is more accurate. So I'm faking a collision detection. Detection. Alright. Get rid of this for a minute. Yeah, because I'm not going to write a whole physics engine just to do a realistic collision detection. So, standard count. It should, in theory, not crash, and it should print something to the screen. So, yes, this is a player. Cool. Okay, so it did it correct. Now, the second thing we need to figure out is... Okay, so that's all well and good. Currently, this is how things are set up. How I'm going to represent the player. Let's throw in static const. Yeah. Can you do a const express on this? I don't think you can. I'll check in a minute. Let's call this... Okay, we don't need static really. I don't really care. It's going to be called... no, what's going to call this thing? Space. Let's pull someone from chat. Right, TT, you've been picked. This excellent username. So we're going to call you the player. There we go. Fantastic. So what we need to do now is effectively go have a system where we can look up the object and actually run it. Now, I could just make global state. So in theory, this is what needs to happen. Oh, actually, I should put that back and kind of print this out. Name. If we can get that far, that's like fantastic. That'll be a massive W. Alright, so we need to figure out a way to have all my objects in a place where I can grab them. Now, immediately what I'm thinking is we have a meta struct that has all the objects in. And we just pass that around. Typed union. Yeah, I think you might be right there. So... Oh, where should we put this? So if each entity has its own thingamajiggy, that's our tag. Union. Let's do an anonymous one. Then we fit player in here. We gotta have another struct, something else. Yeah, let's make a couple of other structs. Put this at the, just so it knows the definition without any issues. I don't. Tree. Float pos 3, I guess. Const char name. Should just duplicate this. What else we got? Mat na. You're a tree. Alright, so we need the tree in here. Tree. So, what we need to do, we've cast the union out, the entity out. We know what type it is based on that, and then we can go swag and go, alright, dot player dot name. And let's do the tree as well. Oops, that's not true. That says true. I think this might be simple enough that I'm not going to be annoyed by this. Alright, so let's go. Yo, there we go. We have a tagged union, and yeah, it knows what to do. So let's just abuse this a bit and throw in 1 and 2. Oh my god, you're sick as a tree now. Yeah, there we go. We'll see your name. Oh. What? Yo, why is the bot telling you off? I apologize, Matt. I don't know why that happened. Bro. I'm so sorry. I don't know why that happened. I have a bot to tell people username, like exclamation mark, like what? No. I've got to bring you back. Okay, so the bot has gone crazy. Okay, I've got to sort something out. I apologize, Matt. Let me gotta pause the timer for a minute. I thought I didn't set this up to have any moderation ability, but here we are. Hey, how do I tell you off? Oh, let's get a bit closer to the mic. So, hide this channel. How do I I want to put the messages back. All right, remove moderator status. I'll do that. Okay. Maybe that'll be useful in the future, but not right now. How do I put the messages back? Okay, I apologize, Matt. I don't know how to fix this. Wait, we can work with it if I just keep trying. I can still see my messages on my end. Interesting. No, it's to everyone else has deleted all your messages, like every single one. Okay. It's because you typed in too many emojis that you triggered the bot and it freaked out. I don't know why it's yelling at you either. Right, okay, so it's not a moderator anymore, at least. So I can't do it again, but I don't know how to restore the messages after that's happened to other people. I can view them. Okay, so we'll just kind of go with that for a minute and just accept that the bot went haywire for like 2 seconds. Yeah, the new ones I can see as well. They're not grayed out as deleted by Nightbot. But yeah, Nightbot is only supposed to be there for, you know, this. Whoops, that's not how you do it. Yeah, that's what it's used. That's what it should come up with my specs. Unless now, because it's not a moderator, it can't post. There we go. That's what it should be there for. But I don't know why it was suddenly going crazy. But anyway, maybe in the future that'll be useful. I don't know, hypothetically, if I'm as big as, I don't know, Deo or something. I don't think that'll ever happen. Anyway, so yeah, apologies for that. Let's get back on task though. Before lunch. So we had an issue here where everything type was yeah, it's crazy to think that that bot could have just banned someone. Yeah, that's what it told. That's what I saw as well. Yeah. Well, we'll just ignore the bot for now. It's not a moderator, it's just a thing. Anyways, okay, so that didn't work. What I wanted to do anyway. We are casting to an entity, right? And that's the only thing we care about. That's everything's in there. And it should say something different. We've got your username. Shake my head. You can never trust a clanker. Yeah, true. Very true. It was literally just meant for that because one live stream I had, like, for some reason I had more viewers than normal, and a few people were asking, trying to use a bot that didn't exist. I was like, oh, I guess I need a bot now. Yeah, so we got rid of it. Yeah, that was a strange. I don't know what. I can't remember why that live stream had any more views than normal. Okay, so is it because it's the same, literally the same size? Oh, what am I doing? Literally typing the word something. Nope. So its type is always... What I don't understand is we've got multiple different entity types here. And now I'm kind of curious. If I do doc, I guess. Now, obviously, this is not going to... We need to now have a doc thing. I don't want to do tree because everything else is tree, but I'm kind of like, okay, is it the order that messes? No, okay, so it is working it out. Okay, so we've got TT's username. Is that because it's going in here multiple times? No, it's not. Okay. It's because my union set up. I'm not very good at unions, so just bear with me a minute. So that should do the opposite, right? Yeah. Alright, so I just need to figure out a tagged union again. Do, 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 do. I know this is a standard environment, but I'm if I can get away with doing this. Are you initializing the inner struct? That's oh, I'm not. No, you're right. It's completely garbage, isn't it? Let me think about this. Let's actually initialize these, because all right. So they're on the stack though. They should have had their default constructor ran, but obviously this is a little bit more. You got to be a little careful. Let me read this a bit longer. It's something I need to learn anyway, so this is going to be useful. All right, let me read this out loud. I'm kind of just sitting here reading. One of my favorite data structures is a tagged union. It is also useful as a variant discriminating union, disjoint union, or some type. Union default initialization might be UB. Yeah, that makes sense. How would you initialize them though? That's interesting. How do you initialize things? So let's just go with something super simple, right? Let's not use structs for a minute. Let's like this, right? If I can't initialize, if they can't be initialized, yeah, because I actually use initialization functions anyway, so I'm kind of like. So let's create an instant function, because I'm kind of curious now. So pos 3. Yeah, it's going to be easier just to write this out like explicitly. What am I doing? Okay, so note 2. Alright, so let's take them and initialize the values. Value equals 99999. The names, yeah, I could just. I don't know where they're gonna live, to be honest, on the stack, but we'll. I'm kind of curious to leave them out for a minute, and I'll come back. So when we initialize this, I need to actually do this anyway. This is actually important. So void. So what I'm going to do is you can just do entity. The problem is it's going to already be it should already have data in before this point. So I'm trying to set up a situation where it has data in, and then we can actually use it. without doing initialization before the entity, if you know what I mean. So I think you're right though. We can just do... No, I see what you're saying. I've misunderstood. Yeah, you mean this, don't you? Let's put this back to player. No, I just misunderstood what you said. And I think it's going to simplify what we're doing. Equals... Yeah, player. Let's not do the most vexing pass. No. And then these will have tree. Same deal. Yeah, I think this is going to simplify. And we can also do an init function. It doesn't even matter, but we should then be able to do that anyway. Because I've written it, I'll use it. And I think, yeah, I can get rid of that now. Okay, it did. I've done that already. Equals tree. And then the same deal again. Dot int it. Let's see. So that's player again. And that said, no, it's just. Excuse me. That should be. Is that firing in here 3 times? Let's see the call stack. Yeah, and if I did that, F11. No, it's in player, yeah. Player name is Matt. No, it is not. Oh, unions are so confusing. But this is good. I really do want to get this to work. This is actually like a really smart idea if I can pull it off. I think accessing the player struct is UB if you don't initialize the player. Oh, really? Interesting. So that would mean standard variant is absolutely necessary then. But anyway, let's okay, the advantage of using tag union is that untagged counterpart is that it's more type safe. Yeah, so the way I want to hear the way he does it. Yeah, I just need to see an example of it being used in the way that we don't expect. Okay, so it's not like you have to initialize the correct struct. Oh my goodness, I'm glad it's nearly lunchtime. This might be something we end up looking up at lunchtime, maybe, but alright. Can you use default initialization in unions? Right, so yes, you can default initialize. Okay, so I'm going to completely ignore that and go to the sources. I have built a working C library that uses constraints. How do I find a constant? Okay. Oh, in that case, maybe we can do that? What? Why are you complaining? Unions can have at most one initializer field. Bro, what is the point then? Unions. I just want to see an example of a tagged union. Let's just see. Let's just type tagged union. Yeah. I don't even care that much about dude, I just need to see the simplest example. So what's the error then? You can only have at most one initializer field. Struct event. Oh, interesting. That's not what I expected. So we do the tag, then based on that, it's like... Then we access the data just raw. So there's no such thing as a player object here, it's just a struct with data in. Interesting. So this is almost like... that's if you're accessing the same data as the type, like vec3. Oh, okay, so let's read this from the top. I think accessing the player struct is you define behavior if you don't initialize the player there. It's not like you just have to always initialize the correct struct. It's not necessary to use standard variant. That's if you want to access the same data as a different type, like a vec3 can be used as a float XYZ. If you want to have the correct data in the entity type, you have to initialize the union when you construct the entity. Initialize the union? I didn't think they got initialized. Alright. So I'm very shaky on unions, as you can probably tell. Initialize. So it's just the same standard thing as... Okay, so when initializing a union, initializer list must have at least one data member in which... Right, okay, so... Okay. Right. When initializing a struct, initialize a list. Okay, so we do a that's a struct and then that's a union. Got it. Okay, let's try that. Okay, that's super useful. Okay. Yeah, because I'm accessing this. Then I need to do a comma. Player? Can I just do it like this? Alright, let's just do this simpler. Okay, so dot entity thingy. And then it's not this then. Equals player. What do I have to do this? Right, okay. Interesting. Okay, so do I have to initialize everything? That's the other question. Right, screw it. Let's just initialize everything. That's in there. Okay. Okay, let's break out this. Equals player. And then dot tree equals this. Out of order initialization. What's the order? Let's try that again. Sorry. This dude, it does not vibe. It's not a default constructor. No, I don't vibe code. Is that what you're referring to? You don't initialize the union members you are not trying to use. You don't initialize them. You set... You're trying to set the same bits. I see. That makes sense. Okay. Thank you for that. Yeah. Alright, so let's try this again, just in a simple case. Entity index equals something. Type equals something. I don't really care. Player equals player? Right, okay, so in theory this should dot play. Okay. It worked then, it didn't work before for some reason. But that's really cool. So then I can do not player but tree with obviously tree. Okay, cool. Let's just see how this works. I'm just gonna break point, and just kind of run through this. And let's see. And what do we get? So it should be player first. Hang on, let's go to this. Okay, let's get rid of these as well. Let's run that again. Okay, there we go. Yeah, I kind of messed up something there. But that's correct. That's your username. And then that's Matt's username. Twice, which is tree. Okay, so we got it. I think we got it there. The union has all its members. Yes, the same location. Yes, that makes total sense. I was just scrolling YouTube and saw this live stream and was like, damn, there are still people coding in 2026. You remind me of Sebastian League. Yeah, someone has said in the past I sound like him, but I'm definitely not as talented or as cool. That's using variants to be nice. You don't have to be so careful. Thank you for the help, by the way, TT. I've actually struggled with unions for a long time, kind of given up every single time. But now it like makes sense, like what's going on. Appreciate that help. It is weird that the initialization function causes everything to kind of break. Though I'm kind of confused by that. Right, so let's try and get the initialization functions working. Why do I need that to work? Because that's how I initialize my objects. So 0. Player int it. So if I'm going to put everything inside entity, this is how I'd need to control it. Obviously this would be tree. Okay, so it's behaving properly. Okay, I don't exactly know what I did, but I clearly messed something up with the naming. Yeah, so it looks like everything's well behaved. There isn't some weirdness happening. Fantastic. Oh, right. Okay, that's fantastic. Guys, I'm going to get my lunch and we're going to watch a video. Now, we're going to do what we did last time. Effectively, I put on a video while I go silent. For the most part, I'll chip in here and there, but you don't want to hear me chewing, I don't think, while I watch a vid. Nice vibes in the stream. Yeah. Thanks, man. Thanks. Appreciate you coming in and saying nice things. I got to go back to work. People might ask me in the office why I'm watching a live stream. No problem, my guy. Appreciate you, dude. See you in the next one. Yeah, thanks, man. Yeah, so... Yeah, I just didn't initialize the types correctly. Thank you, TT. I will write up notes about this. Yeah, so we're going to watch a vid. I'm going to get my lunch. I don't exactly know what we're going to watch, so let's pull something up. It just happens to pick the player struct. I see. So it just arbitrarily got it right. Arbitrarily got it right. Well, arbitrarily just picked the player. Okay. Thanks. Thanks again. Let's pull up a video. Obviously I won't play the music while this is. So we have some resource videos in my. So I'm tempted to try this. I was talking about this yesterday. CPPCon, more simplicity and practical data-oriented design. Yeah, so we could just give that a shot. I like data-oriented design. I've watched that. So yeah, that's what I'm going to pick. I don't, unless there's a fire suggestion in chat, I think that's what we're going to watch. And since the name is the same in memory. Ah, right, okay. So if I had more different data types, it would have completely blew up. Thank you for thanks for all the help explaining stuff, TT. Yeah, so we'll pop this up, and then I'll grab my lunch out of the fridge. We won't watch all of this. We'll watch about 20 minutes or so around here. That's usually when I've like eaten